Hi everyone, Miss Shearhart here, and today I'm going to be telling you how to go about doing the calculations on this mole calculations worksheet that you guys got. So I'm going to do an example from number 1, number 2, and number 3, and then you guys can go ahead and finish the rest of the worksheet checking your answers down here. Okay, so let's have a look at what we're doing. So remember, we were doing this before in class. We're always setting this up the exact same way. What we're looking for is equal to what we know multiplied by a conversion factor. And sometimes there can be more than one conversion factor and we have to do 2 or 3 steps. So in our first example, like we did in class, how many eggs are in 742 dozen? What are we looking for? The number of eggs. So the number of eggs equals, what do we know? We know there's 742 dozen. Then we're going to multiply by our conversion factor. Our conversion factor is that there are 12 eggs in every 1 dozen. And I know I'm going to write it this way with 12 eggs on the top and 1 dozen on the bottom because the dozens on the top and the dozen on the bottom cancel each other out. That way I'm left with eggs. So I punch this into my calculator and I get 8,904 eggs. However, this number here has 3 significant figures. 12 eggs is an exact number, so it's got an infinite number of significant figures. So my lowest number of significant figures is 3, which means my answer can only have 3 significant figures. So I really have to write this down as my final answer, 8.90 times 10 to the 3 eggs. I don't even need to write this step, but I just wanted to show you guys because that's what your calculator will show you. Okay, let's try another one that involves 2 steps. So now it asks us how many seconds are in 1.33 hours. Okay, what are we looking for? We're looking for the number of seconds equals, what do we know? There's 1.33 hours. Then we're going to multiply by our conversion factor. We know that there are 60 minutes in 1 hour. I'm putting it this way so that hours cancels out with hours. That leaves me in minutes, but I don't want to be in minutes. I'm looking for the number of seconds. So I have to keep going. Multiplied by, there's 60 seconds for every 1 minute. Now minutes cancels with minutes and I'm left with seconds. Great, that's what I'm looking for. So I punch this into my calculator, 1.33 times 60 divided by 1 times 60 divided by 1 gives me 4,788 seconds. But this has 3 significant figures. These are infinite significant figures because they are exact calculations. There's exactly 60 seconds in 1 minute, exactly 60 minutes in 1 hour. So they don't count for our sig figs. So our answer can only have 3 sig figs. So I have to write this as 4.79 times 10 to the 3 seconds. Okay, so now we're going to actually do the chemistry. That was just conversion factors like we did in class. And now we're going to do our actual worksheet with the mole. So remember, the mole is just another conversion factor, just like the dozen. Okay, so let's see our very first question on our worksheet. Remember, we're working on this worksheet here that you guys have. Okay, it says, calculate the number of neon atoms in 2.0 moles of neon. So what am I looking for? Number of neon atoms equals, what do I know? That there's 2.0 moles of neon. Remember, the short form for moles is just MOL, multiplied by my conversion factor. So our new conversion factor that we learned in class is Avogadro's constant. And Avogadro's constant is that there's 6.02 times 10 to the 23 either atoms, molecules, or formula units per 1 mole. Here I'm dealing with atoms because I'm talking about the element neon. So because I have moles on the top, I want moles on the bottom so that they will cancel each other out. Line up my equal signs. And now I'm going to use my calculator. So I'm putting 2.0, which is the same on your calculator, just putting 2, times 6.02 exp23 divided by 1 gives me this 1.204 times 10 to the 24. But my number of sig figs can only be 2 because my lowest number of sig figs is 2 here. 3 sig figs here, so I can only give 2 sig figs. So I'm going to say that this is 1.2 times 10 to the 24 atoms, because my moles have canceled out and I was looking for atoms. In number 2a, we're looking for the number of moles of silver represented by 6.02 times 10 to the 22 silver atoms. What am I looking for? The number of moles of silver equals. What do I know? It's 6.02 times 10 to the 22 silver atoms. Always multiply. Now my conversion factor. Since atoms is at the top, I need atoms at the bottom. So my 6.02 times 10 to the 23 atoms goes in the bottom for every 1 mole. Now the atoms will cancel with the atoms. I'm left with moles, which is what I want. So I'm going to punch this in. 6.02 exp22 times 1, which does nothing, divided by 6.02 exp23 gives me 0.1. I'm not going to write 0.1 because I have to have 3 significant figures. That's my lowest. 1, 2, 3, 1, 2, 3. So my answer is actually 1, 2, 3 significant figures, 0.100 moles. And finally, for number 3, calculate the number of carbon atoms in 4.70 moles of C3H8. I'm looking for the number of carbon atoms equals, what do I know? 4.70 moles C3H8 times my conversion factor. Okay, C3H8 is not an element. C3H8 is a compound. And because I have nonmetal and nonmetal, this is a molecular compound, so I'm dealing with molecules. So I know that there are 6.02 times 10 to the 23 molecules in every 1 mole. So now my moles have canceled out and I'm in molecules, but that's not what I want. I want the number of carbon atoms. So I have to keep going, multiplied by, so I need my second conversion factor, and I'm going to come down here because I'm out of space over to the right. Okay, so now I'm in molecules. So now I look at my molecule. Okay, here's my molecule, C3H8. Okay, so for every 1 molecule, if I look at my formula, there's 3 carbon atoms. So now the molecules on the top will cancel with the molecule on the bottom. And I'm left with carbon atoms, which is what I want. Okay, so this was a 2-step problem. First, we had to convert from moles to molecules, and then from molecules to carbon atoms by looking at the formula. So now I can punch all of this in to my calculator. Oops, let me see that. 4.70 times 6.02 exp23 divided by 1, which does nothing, times 3 divided by 1 equals, here's what my calculator shows me, 8.4882 times 10 to the 24, but I have to look at my sig figs. Okay, so here I have 3 sig figs, here I have 3 sig figs. When I'm counting the number of carbon atoms in a molecule, that's always infinite sig figs because that's an exact count. So my lowest is 3 sig figs. So my answer must have 3 sig figs. So I'm going to round this to 8.49 times 10 to the 24. And what's my unit? Moles is gone. Molecules is gone. I'm left with carbon atoms, which is what I want. Thanks, guys. See you next time.